This is what a lot of your homework is going to be about. Actually, we'll do more of the story problems on Thursday, but using a thing is important. All right, a potter wants to make and sell serving bowls and plates. A bowl uses 5 pounds of clay. A plate uses 4 pounds of clay. The potter has 40 pounds of clay and wants to make at least 4 bowls. The profit on a bowl is $35. The profit on a plate is $30. How many bowls and how many plates should the potter make in order to maximize the profit? Use the information and write down the constraints. All right, wow, that is a lot of information, a lot. I'm going to tell you right now, okay, that we're not going to worry about this part that has to do with the profit. That's not the constraint. That's going to be what's called our objective function later on. So right now we're just going to do the constraints. Now, we're going to have to worry about what 2 different things do I have? What am I trying to make? Plates and bowls. I need to assign one of them as X and one as Y. So what are we going to do? Plates as Y. Perfect. Okay. A bowl uses 5 pounds of clay. A plate uses 4 pounds of clay. Now, the potter has 40 pounds of clay. So, how many pounds for each bowl? 5. So, I'm going to write 5x plus 4y equals 40, because that's how much pounds that he's got to use to make this. He wants to make at least 4 bowls. All right, if you say that you want to make at least 4 bowls, what does that mean? That you want to make 4 or? Okay, but what we're going to use the x, and we're going to say that x has to be bigger than or equal to 4. Okay? Now, let me ask you another question. Because x represents how many bowls you make, does it make sense that x is negative? No. So that's one of our constraints, is that x has to be greater than or equal to 0. Does it make sense that plates is negative? No. So then that's the other constraint, is that y is greater than or equal to 0. How many constraints do I have? I have 4. Let's go ahead and graph these 4 and see. Now, I do not have a grid in the middle, so just anywhere, make yourself an x and a y axis. What I might do is I could go right along the bottom, okay, right there, and right here. Now, what is the only quadrant that I have? The first quadrant. And then this is y. Okay, so I've got my x and I've got my y. That takes care of these 2 constraints. Now, x has to be bigger than or equal to 4. So I'm going to count off 1, 2, 3, 4. And I'm going to make a straight line there. And shade to the right, because it has to be bigger than. Everybody okay with that? Okay. So check that off. Graph that. Now the last one is 5x plus 4y has to equal 40. Well, now wait a minute. This is not an inequality. I can't shade. Would it make sense that this is less than or equal to 40 or greater than or equal to 40? Probably less than, because all I have is 40 pounds. Yeah. You know what I'm going to do with this equation? Well, what do you think I should do?
Solve for y.
Let's solve for y. So what do we want to do first? Yeah, I've got 5x plus, I'm going to do it over on the side here. So I'm going to subtract 5x from both sides. Okay, so I end up with that right there. What might be my next step? Yep, make sure we are fair. We divide everything by 4. And what's 40 divided by 4? 10. Okay, now I think I'm okay to graph this. So, what is my y-intercept? 10. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my slope is what?
-5 over 4.
Okay, so I go down 5 and to the right 4. And it intersects right there. And then 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Say that again?
You said down 5?
Yep,
No.
down 5. And then to the right 4. And I need to shade y is less than that line. So I'm going to shade underneath. And this area right here, what's that called again? Yep. So right here, number 3 asks us to find the points of intersection. That's another way of saying find my vertices. Okay? All right. So what are my vertices in this case? 0, 4. What's the other one?
4, 5.
Oh, you're right. Yeah, what did someone say?
4, 0.
Yeah, I think it is 4, 0. It's the other way around. X goes first. Okay, so 4, 0. And what's this one?
8, 0.
Yep, that's 8, 0. Oh, and I'm sorry. Yeah, go ahead, Ethan. What's this number up there?
4, 5.
4, 5. Okay. All right, so now we've answered that. Now the next, number 4, says that they want us to write an equation for the total profit. So that part up there that I ignored, now I have to write an equation for it. And this has to do with money, okay? And this is how things work. All right, the profit of a bowl is $35. The profit on a plate is $50. So, 30, yep, you're right, not 50, wow. Okay, so, the way we're going to write it is we're going to write P, and then I'm going to put a little XY in parentheses. Why do you think I'm doing that?
Multiplying the coordinates of x.
Well, because I'm using, you know how we write f of x sometimes?
Yeah.
And then I say like 2x plus 3. Well, in this one, we're using x and y, so that's why I'm putting that there. If you want to just say p equals, that's fine. You don't need the x and the y there. Now, how much did we make on a bowl?
35.
So let's go 35x plus
30y.
30y. Now it says evaluate the objective function at each vertex. Yes, I can. There we go.
Plug in x and y.
Yes, that's right. We're going to plug in x and y. So how many answers am I going to have here? I'm going to have 3. So first, I want to do p of 4 and 0. Okay, so I'm going to plug 4 in for x, 0 in for y. So that's going to be 35 times 4 plus 30 times 0. And what do you get? What's 35 times 4?
130. No, 140.
Yep, 140. Okay, so let's test the next point. What's the next point? 80?
Yeah.
Ooh, that one looks pretty good. 35 times 8 plus 30 times 0. Okay, what's 35 times 8? 280. And then we're going to try the last one, which is, what did we say it was? 4, 5. 35 times 4 plus 30 times 5. So we go 35 times 4 plus 30 times 5, and we get 290. Ooh, just edged it out. So, in order to make the most money possible, how many plates and how many bowls?
4 bowls by 5 plates.
Yep, 4 bowls.
Use that one anyways because you want to make at least 4.
Yeah. Well, no, you can also use 4-0. You have enough clay.
Yep, you do. Did everybody get that? Sorry. I just want to make sure that, is there anything? Yep, that's good. Okay, so that is an example of how to do that, okay? All right. Okay, we're going to do one more example together, and then I'm going to let you start your homework, okay?
Is this extra homework?
No, we're going to work on these more Thursday. Homework? Well, okay, but I think that we need a little more practice in coming up with the equations. So your homework tonight, it's going to be more like this, where I give you the equations, and then I give you like a P equals. You graph them and you test them to find the max or the min. Okay? We're going to work more on these types of things Thursday, but I wanted to at least start them today. Okay, so we just have one more to do, and then we'll get started. All right. Trees in urban areas help keep air fresh by absorbing carbon dioxide. A city has $2,100 to spend on planting spruce and maple trees. The land available for planting is 45,000 square feet. Spruce trees cost $30 to plant and require 600 square feet of space. Maple trees cost $40 to plant and require 900 square feet of space.
Is that each?
Yes, each. Say that? Oh, just don't worry about it. I got this from somewhere else. Spruce trees absorb 450 pounds per year of carbon dioxide, and maple trees absorb 300 pounds per year of carbon dioxide. How many of each tree should the city plant to maximize carbon dioxide absorption? Now, first of all, what part of this equation does not have to do with the restrictions?
How much carbon dioxide? Oh my God.
Whatever they are asking for, that equation is what we use in the end. So this part right here, we're going to save that for the end. My constraints have to do with all this other information. Okay? So let's talk about my constraints. Once again, can x be negative? No. So that's a constraint. X is going to be greater than or equal to 0. What's my other constraint?
Y.
Yep, y is also greater than or equal to 0. Now, they talk about two things up here. What are the two things they talk about above?
How much square feet it needs and how much it costs.
Yeah, how much square feet it needs and how much it costs. Let's do one with cost first, okay? All right. How much money does the city have? $2,100. Does it have more than this? No. So it's going to be less than or equal to 2,100. Does that make sense? All right. How much? Oh, you know what we never did? We never figured out what was going to be X and what was going to be Y. What do you think? Okay, X were going to be the spruce trees, and Y can be our maple trees. All right. So, how much does it cost? Because this has to do with cost. How much does it cost for a spruce tree? 30. So that's going to be what? 30X? And then plus 40Y has to be less than or equal to $2,100. Okay? And now the next thing is about how much space they take up. I mean, I love maple trees, but it looks as though maple trees take up a lot more space. Probably because of their root system and maybe because of the shading that's going to be going on. All right? So, we've got 600X plus 900Y. And how much space do they have?
45,000 square feet.
That is a lot. Okay, and now we have to somehow, we're going to have to graph these. Okay, so let's start. Let's start by at least knowing that this is going to be my quadrant 1. Okay? Instead of, can I show you guys, I mean, do you want to solve for Y? Start with this one?
Yeah, so the other, like the two ones that are just greater, then we put the 0 to shade the whole thing over, so
Yeah, we'll just, all this is going to be shaded, yes. Yep. But I'm going to start with this one right here. So what's the first step in getting Y by itself? Subtract my 30X. So I'm going to take this one, and we're going to say 40Y is less than or equal to negative 30X plus 2100. Then what am I doing? Is someone with a calculator? What's 2100 divided by 40? 52.5? Okay. Okay. All right. Yeah, and I guess we would say 50, wouldn't we, Marshall? Because we're talking money. So, all right. So this is one of them that I need to graph. Okay. But I need to also graph this one. It's kind of running out of room here. But I'm going to say 900Y is less than or equal to running out of room. Okay, divide by 900. And what is 50? That's what that is? All right. Now, I don't think I have 50 squares over here. So how about we count by 2s?
4, 5.
5 might get a little tiny because my slopes are kind of small. So let's try to just count by 2s, okay? 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Uh-oh, what happened? Did I run out of room? All right. Well, how about if X is 1? Let's go. Okay. I don't want to extend it, but I need to make a line. So what I'm going to do is just find 2 points on either one of these lines, okay? So the first thing I want to do is I'm going to put 10 in up here, all right? And so I'm going to take my calculator, and I'm just going to say negative 3/4 times 10 plus 52.5. And I get 45. That's still kind of big, but I'm going to plot that point, and we know that it's going to be way up there. So now, let's try to do it with x equal to 20. 37.5. So when x is 20, on the graph is 37, there's 30, 32, 4, 6, 7.5, right about there. Okay? I'm going to do one more point. I'm going to do 30, and it's 30. So when x is 30, y is 30. And might as well do one more point and try 40. $22.5. Right. So what I'm going to do is I'm going to try to get my line like this. You know what, Marcia? We should have maybe gone by 5s. Kind of a big graph. All right. So now I need to graph this one, and I'm going to do the same thing, except for this is 2/3. And we'll start with 10, and this is 50. And it's 130 divided by 3, 43.3. So at 10, it's a little bit above, and it's just a little below it, right there. All right. Let's try 20. And 110 divided by 3, 36 2/3. So 30 and 2/3, right about there. That's almost where they intersect. Uh, 30 is 30 again, so they do intersect at that point. And I have a feeling that 40 is a little bit lower than where it is. 23.3. Okay, so the line is really close, but it kind of goes like that. Okay? So this point, my vertices, my points are 30, 30, where it goes through here, and this one right here. And this one, which is $70. Okay, so you test those 3 points, but we have, I know you guys, you're being very patient. We need to come up with the equation right here. Spruce trees absorb 650 pounds of carbon dioxide, maple 30. So my formula that I need for carbon dioxide is I'm just going to say C equals, for that's carbon dioxide, and it's going to be 650X plus 300Y. And then you test each of these points. The one that's the largest That is how many spruce trees and how many maple trees you should plant.
So it's 30.
Yep, I would have to go with you, Marshall, and say that yes, it is probably 30-30.
Well, that's the most trees in general.
That is the most trees in general. When you add the two up, that's the greatest number of trees that you can get.